हेलो फ्रेंड्स, आज हम स्टार्ट करेंगे इलेक्ट्रोकेमिकल सेल्स। इलेक्ट्रोकेमिकल सेल्स दो प्रकार के होते हैं। पहला गैल्वेनिक और वोल्टेक सेल एंड दूसरा इलेक्ट्रोलाइटिक सेल। जैसा कि हमने पहले लेक्चर में पढ़ा था, इलेक्ट्रोकेमिस्ट्री में हम दो तरह के केमिकल रिएक्शंस पढ़ते हैं। पहला वैसा केमिकल रिएक्शन जिसमें हम केमिकल एनर्जी यूज़ करते हुए इलेक्ट्रिकल एनर्जी प्रोड्यूस करते हैं, और दूसरा जिसमें हम इलेक्ट्रिकल एनर्जी यूज़ करते हुए केमिकल एनर्जी प्रोड्यूस करते हैं। सो गैल्वेनिक और वोल्टेक सेल में हम पहला टाइप ऑफ केमिकल रिएक्शन पढ़ते हैं इन विच अ केमिकल एनर्जी इज कन्वर्टेड इनटू इलेक्ट्रिकल एनर्जी, जबकि इलेक्ट्रोलाइटिक सेल में हम दूसरा केमिकल रिएक्शन पढ़ते हैं इन विच इलेक्ट्रिकल एनर्जी इज कन्वर्टेड टू केमिकल एनर्जी. So let us see how a galvanic or voltaic cell looks like. So this is a typical example of zinc copper galvanic or voltaic cell. This zinc electrode is dipped into zinc sulfate solution, and this copper electrode has been dipped into copper sulfate solution. These two electrodes, zinc and copper, they are connected by a conducting wire, and the two electrolytic solution, zinc sulfate and copper sulfate solution, is connected by a salt bridge. So this makes a complete circuit in which a loop is formed. Okay, so now let us see what are the chemical reactions that takes place into this galvanic cell. As you know that zinc is more electropositive than copper, so zinc has more tendency to lose an electron than copper, and copper will be forcibly reduced by zinc. So zinc loses 2 electrons to become Zn2 plus and gives out 2 electrons. So zinc, one of the zinc atom from this electron that gets dissolved to form Zn2 plus ion, and the 2 electrons which is liberated goes up along this conducting circuit and is passed to the copper. So the 2 electrons comes over here. Since there are so many of Cu2 plus ions in the form of copper sulfate, so one of the copper sulfate ion accepts these 2 electrons and it forms a copper metal. So Cu2 plus accepts 2 electrons to form a copper metal, and this copper ion will get deposited into this copper electrode. So let us consider an initial case in which equal concentration of zinc sulfate and copper sulfate is placed, and equal number of zinc and copper ions are there into the solution. For simplicity, I have drawn 6 Zn plus ions into the zinc sulfate solution and 6 copper ions into the copper sulfate solution. Now, as one of the zinc atom which is there in the electrode, it dissolves to give Zn2 plus and 2 electrons. These 2 electrons will travel to this copper electrode, and these 2 electrons will be attracted by one of the copper ion, and it will react to give one copper atom. So I have drawn it here. Again, some another zinc atom will dissolve into the solutions to give Zn plus ion, and the extra electron will travel over here and it will react with one of the copper ions to give copper atom. Again, some more zinc 2 plus ions will form, and this copper ion will get consumed to deposit copper atom at the surface. So this will keep continuing as long as there are ions available for losing electrons as well as for gaining electrons. So ultimately what will happen is all this zinc atom will dissociate, it will ionize to give Zn2 plus, and copper ions will accept electrons to become copper atom. If we compare with the initial phase, we had taken 6 Zn2 plus ion in the zinc sulfate solution and 6 copper sulfate ions in the copper sulfate solution. After some time, what will happen is 6 more Zn atom has dissociated or simply ionized to give out electrons, and all the copper ions that was present into the copper sulfate solution, it has accepted electrons to become copper atom. As more and more Zn atom ionizes to give Zn2 plus ions, more electrons will come over here, but that will not be neutralized by any copper ion to become a copper metal. So now there is some sort of charge imbalance into the solution, where we have excess of negative charge into this and excess of positive charge into this. So this is where the salt bridge comes into picture. A salt bridge is generally packed with an ionic salt, and the function of the salt bridge is to not let any kind of charge build up into any of the electrolyte solution. So let us see from the beginning again what happens when first ion gets charged into the electrolyte solution. So this was our initial scenario in which we had considered equal concentration of zinc sulfate and copper sulfate into both the beakers, but that time we showed only zinc plus ions and copper plus ions. We did not show the sulfate ions. So let us draw it here now. Now we have equal amount of positive ions as well as negative ions into each of the beaker. So there are 6 Zn2 plus ions and 6 SO4 minus ions into this zinc sulfate solution, and 6 copper 2 plus ions and 6 SO4 2 minus ion into the copper sulfate solution. Now when one of the zinc atom ionizes to give Zn2 plus ion and 2 electrons, that passes across this conducting wire to this copper electrode. So let's say this copper ion accepts these 2 electrons to become a copper atom. So it becomes a copper atom and it gets deposited onto the copper electrode. In this case, what happens is there is an excess of positive charge into this solution, and there is an deficit of positive charge into this solution. So sulfate we have 6, right, and copper 2 plus ions, it is only 5. So the function of the salt bridge is to avoid buildup of any charge excess or charge deficit. So let us say that this salt bridge is packed with K2SO4. So what it will do is one of the K2SO4 will dissociate to provide negatively charged ion to the positive access chamber and positively charged ion to the negatively charged access chamber. So this copper sulfate will dissociate into 2K plus and SO4 2 minus, and since this chamber is positively charged and this chamber is negative, it has negative access charge, so what will happen is sulfate ion. So sulfate ion will pass on to this, and 2K plus ion will pass on to this chamber, such that the charge balance is maintained in both of the chamber. Again, when an additional Zn plus is dissociated to give out Zn2 plus, then what will happen? One of the copper will again combine with electron to get deposited onto this surface. Then again 2 copper plus will be obtained from this salt bridge, and this one more sulfate ion will dissolve into the solution. So the function of the salt bridge is to maintain charge equilibrium in both the chambers, and it will keep on going and on and on and on until or unless one of the substances or reactants is exhausted. So let's say this zinc completely dissolved into the solution, then this reaction will stop. Or let us say this salt bridge, which has a packing of copper sulfate, it gets consumed, then also this reaction will stop. Or maybe let us say all the copper ions which is there into this solution, it gets exhausted, then also this reaction will come to an stop. So this is how a zinc copper voltaic cell works. So let us see an animation how it works. In this animation, as you can see, that zinc is oxidizing to give out Zn2 plus ions, and the electrons that is produced goes through this conducting wire and lights the bulb, and it is passed to the copper electrode. At the copper electrode, copper ions react with this electron to form copper atom, and the salt bridge that is made up of KCl. So Cl minus travels to the excess Zn plus compartment, whereas the K plus ions flows to the excess electron compartment. Similarly, we can see take another example. In this case, this galvanic cell is made up of iron and copper. So in this case, iron will oxidize to give out iron ions. Iron ions will dissolve into the solution. The electrolyte is iron nitrate in this case and copper nitrate in the other one, and the salt bridge is made up of KNO3. So we have nitrate ions common to the two electrolytic solutions as well as the salt bridge. Now as the iron oxidizes to give Fe2 plus and excess electrons, these electrons may be used to run any electrical equipment, and the excess electrons that comes to this copper electrode, it attracts the Cu2 plus ions at the copper electrode. Since there is a buildup of negative charge into this, so what happens is the sulfate ions attracts the positively charged nitrate ion, not sulfate, it is nitrate. So the nitrate ion into this chamber, copper nitrate solution chamber, excess nitrate ion attracts the positively charged potassium ion, whereas in this case in the iron nitrate solution we have excess of iron ions. So it attracts the nitrate part of the ion into this chamber, and ultimately what happens is both the chambers are electrically neutral. So this is how a galvanic cell works. A galvanic or voltaic cell is used to produce electrical current as it is happening in this case, whereas the other one, which is an electrolytic cell, an external power source is applied to drive chemical reactions into the solution. So let us see how an electrolytic cell looks like and what are the chemical reactions that takes place into this one. An electrolytic cell is mostly similar to galvanic cell. So like in the galvanic cell, we have an anode and a cathode, and we have two electrolytic solutions connected by the salt bridge, and the two electrodes connected by an electrical conducting wire. But the only difference over here is we have connected an external voltage supply, and this is the voltmeter just to measure the voltage difference. So don't get confused, this is not a very complicated diagram. So what has happened is we have just added a voltage supply at this point as in case of galvanic cell. So this is just a voltage supply, do not get confused with this complicated diagram. We just have a voltage supply just added at this point. Okay. Now what happens in an electrolytic cell? As I said, an electrolytic cell is same as a galvanic cell, only thing is has a external voltage supply, and which is greater than the electric potential of this cell. So in this case we have taken the zinc copper galvanic cell, and it has an electric potential of 1.1 volt. We'll see how this 1.1 volt comes out later. Now at this point we will just assume that it is 1.1 volt. So when we apply an external voltage of more than 1.1 volt, then the same galvanic cell becomes an electrolytic cell. Okay. So instead of electrons going from here to here, what will happen is electrons will go from here to here. So the external source will be supplying electron source, and the direction of charge will be like this. It will be reversed under the force of external voltage supply. So the zinc that was getting oxidized will now get reduced. So Zn2 plus will accept 2 electrons to become Zn, and Cu, which was getting reduced, will get oxidized to form Cu2 plus and 2 electrons. So the entire chemical reactions will get reversed. So as you have seen in the case of rechargeable batteries which we use in remote or toys, so when it is discharging, it works as a galvanic or voltaic cell. But when we charge it, then it becomes, during the process of charging, it becomes an electrolytic cell. So let us discuss in detail the three scenarios when the external supply is less than the cell potential, equal to the cell potential, and greater than the cell potential. There are three cases possible in a galvanic cell when we apply any external potential source. The first one is that the external voltage that is being applied is less than the cell potential of the galvanic cell. In this case, so the tendency of the electrons to move from zinc to copper side is greater than the tendency of the electrons to move from copper to the zinc side. So because of this, there is a net flow of electron from zinc to copper, and zinc dissolves into the solution. Zinc will ionize and it dissolves into the solution, whereas copper will accept the electrons and it will get deposited on the copper electrode. In the second case, the external voltage supply applied is equal to the cell potential of the galvanic cell. So since the tendency of the electrons to move from copper to zinc is equal to the tendency of electrons to move from copper to zinc, they are equal. So there is no net force that works on the electrons, and because of this there is no flow of electrons and hence no chemical reaction. In the third case, external voltage that is being applied is greater than the cell potential. So in this case what happens is the tendency of the electrons to move from zinc to copper is less than the tendency of the electrons to move from copper to the zinc. So because of this, what happens, electrons move from copper to zinc, or we can say current moves from zinc to copper, and since zinc is accepting electrons, zinc will be reduced or zinc will be deposited on the zinc electrode, and copper will dissolve and ionize, and it will get dissolved into the solution, copper sulfate solution. So this was all about galvanic cells. We will stop here and discuss in more detail about electrochemistry in the next lecture.